Good afternoon, students. In this video, I am going to explain about soil moisture irrigation relationship, saturation capacity, field capacity, moisture equivalent, soil moisture content, permanent wilting point, temporary wilting, ultimate wilting, optimum moisture content, and root zone depths are the parameters in soil moisture irrigation relationship. Saturation capacity. It is defined as the total water content of a soil when all the pores of the soil are filled with water. This is also known as the maximum water holding capacity of the soil. Most crops except rice cannot withstand saturated soil condition for more than 2 to 5 days. Saturation capacity is the upper limit of possible moisture content. It is expressed as equivalent centimeter of water per meter of soil depth. Field capacity. It is defined as the maximum amount of moisture which can be held by a soil against gravity. Thus, immediately after the gravitational water has drained off from a saturated soil, the moisture content held by the soil is the field capacity of the soil. The field capacity is usually expressed as a percentage. Field capacity is equal to weight of water retained in a certain volume of soil divided by weight of same volume of soil into 100. Moisture equivalent. It is defined as the percentage of moisture retained in an initially saturated sample of soil 10 mm thick after being subjected to a centrifugal force 1000 times gravity for a period of 30 minutes. The moisture equivalent may vary from about 5% for coarse sandy soils to more than 50% for heavy fine textured clay soils. The moisture equivalent of a soil can be quickly determined in a laboratory and it is used as an approximate measure of field capacity. For medium textured soils, ME is equal to FC. For sandy soils, ME is more than FC. For very clay soil, ME is less than FC. Soil moisture content. The amount of water present in a soil is termed as soil moisture content. It is expressed as mm of water depth present in 1 meter depth of soil. It is not constant but varies with time. Permanent wilting point. It is defined as the amount of moisture content present in the soil when the plants become permanently wilted. A plant is considered to be permanently wilted when it does not regain turgidity even after being placed in a saturated atmosphere. But it may, however, regain turgidity if water is added to the soil. At the permanent wilting point, the films of water around the soil particles are held so tightly that the plant roots cannot extract enough moisture at sufficiently rapid rate to satisfy transpiration requirement, thus resulting in the wilting of the plants. It is expressed as the weight of the moisture held by the soil per unit weight of the dry soil. When the plants are permanently wilted, the permanent wilting points differ widely for different soils, but have approximately the same values for different plants grown on the same soil. The value of permanent wilting percentage may be as low as 2% for light sandy soils, and it may be as high as 30% for heavy clay soils. Temporary wilting. Temporary wilting of plants may occur on a hot, windy day, but plants recover from wilting in the cooler portion of the day or during the night without any addition of water to the soil. Thus, temporary wilting of plants may occur even without much reduction in the soil moisture content. Ultimate wilting. When ultimate wilting occurs, the plants are completely wilted, that is, the plants die away and they cannot recover from wilting even after the addition of water to the soil. The ultimate wilting point occurs at the hygroscopic water content. Optimum moisture content. For satisfactory growth, plants require readily available water in the soil. Excessive flooding and deficient soil moisture are not conducive to plant growth. Thus, optimum moisture content in the soil is required for optimum plant growth. The optimum moisture percentage is the moisture content in the soil corresponding to which optimum growth of plants takes place. Root zone depth. Root zone depth, it is a depth below the ground surface in which the crops develop root system to derive water for growth. The depth of root zone in irrigated lands depends on soil type, subsoil formation, depth of water table, kind of crops grown, and amount of water applied during irrigation. Look at the screen that the roots grown below the surface in the soil, and the roots are covered, the soil layer is called as the root zone or root zone depth. The next chapter is depth and frequency of irrigation. Frequency of irrigation. Soil moisture in the root zone varies between field capacity, that is upper limit, and wilting point, lower limit. The soil moisture is not allowed to deplete up to wilting point. For satisfactory growth, the moisture content in the soil should be between field capacity and optimum moisture content, which is the readily available moisture. When watering is done, the amount of water supplied should be such that the water content is equal to the field capacity. Water will gradually be utilized consumptively by plants after the water application, and the soil moisture will start falling when the water content in the soil reaches the optimum value. Fresh doses of irrigation may be done so that water content is again raised to the field capacity of the soil. The frequency of irrigation is controlled by the amount of available water contained in the root zone of the soil and the consumptive use rate. The depth of water to be given during each watering is given by capital D is equal to YD divided by W in bracket FC minus MO, where Y is unit weight of soil, D is depth of root zone, capital M small o optimum moisture content expressed as ratio, W is equal to unit weight of water, FC is field capacity expressed as ratio, frequency of irrigation F is equal to D by Cu, where D is equal to depth of water in centimeter, Cu is equal to rate of daily consumptive use in centimeter. This is about the depth and frequency of irrigation. Thank you.